This topic is all about arithmetic operations with functions. Arithmetic operations meaning add, subtract, multiply, and divide. So it shouldn't surprise anyone that if functions, if their job is to take in numbers and spit out other numbers, that, well, you can do stuff that you would do with regular numbers to them. And one thing you can do with regular numbers is arithmetic operations. What this topic is really more interested in is the domains rather than the actual operation. Because adding, subtracting, multiplying, dividing, that should be a piece of cake. It's wondering what the heck the domains are. Let's just do a quick review of finding domains of functions first. We need to be interested in domains because not all functions can utilize every single x value in the whole universe. For example, we know that if we had a function f of x equals 1 over x, using x equals 0 would be, quote, bad, right? Because we've always been taught, you can never ever divide by 0. In this example, say the square root of x, using, say, x equals, negative 5 would be, quote, bad, because at least in the field of real numbers, you can't take a square root of a negative number and produce a real number. It produces complex numbers, but we're not talking about that yet. So, to find domains algebraically, these are basically the two conditions that we need to consider. We want to avoid dividing by 0, and we want to avoid taking an even root of a negative number. So, to find domains, one over stuff, you're going to set the denominator equals not to 0 and solve. To find domains of an even root of stuff, set the stuff inside the radical greater than or equal to 0 and solve. That's just it, right? So it should be very easy. It's a matter of algebra to find domains of functions. If you have a fractional function, set the denominator not equal to 0 and then you solve. If you have an even root of something, set the radicand greater than or equal to 0 and solve. So how do the domains change when I start to add, subtract, multiply, and divide functions? Well, the idea is very simple. When you add, subtract, multiply, or divide, and I'm going to put a little asterisk by divide because dividing has some extra little tidbits to it, but for the most part, when you add, subtract, multiply, divide functions, the domain will be the overlap of the individual domains of the functions. In other words, if I ask you to do an add, subtract, multiply, and divide problem, and then ask you to find the domains, you want to find the domains of the individual functions separately, and then look at them together and see where they overlap. Let's take a look at two examples here. Right? Oh, actually, before we do that, let's talk about the little asterisks here for the dividing part. If you are dividing, say, f over g, then that g function cannot equal 0 for the aforementioned reason. So in a division problem, you also have to exclude whenever the denominator equals to 0. We'll take a look at a couple of examples here. Say, for example, I asked you for f of x equals x plus 1 and g of x equals the square root of 4x minus 3, find f plus g and f over g and their domains. So this is similar to how your practice problems will be worded. They'll put it as one, but clearly you can see this is two separate questions. So I'm just going to label this as question number 1, and I'll label this as question number 2, right? Just to make things clear in the notes. So let's go ahead and do that. Question number 1 is very easy. What's f plus g? Well, you just literally take the f function and add it to the g function. So f plus g of x is the f function, x plus 1, plus the g function, square root of 4x minus 3. Do you have any like terms? No? Guess what? There's your sum. You are done. All we have to do now is find the domains. And then to find the domains, you just find the domains separately. So the domain of x plus 1. So that's the f function. Now, again, when it comes to domain, you're looking at two things. These are the two bad things to do. Dividing by 0 and taking an even root of a negative number. So I'm going to ask myself those questions. Am I doing any division? Am I doing any radicals? So x plus 1, is there any division going on? The answer should be no. It's just a linear function. Do I see any even roots? A square root, fourth root, sixth root? No, you don't. So guess what? The domain is all real numbers. The domain is everything. So the domain is negative infinity to positive infinity. Let's do the domain of the second part. Square root of 4x minus 3. Again, I'm going to ask myself those two questions, dividing and radicals. This function, is there any division going on? The answer is no. This function, is there any even roots? And the answer is yes. So to find the domain algebraically, if you have a square root, all you have to do is set the inside stuff greater than or equal to 0. And then you just simply solve. So add the 3 over, and then divide out the 4. That is your domain. But of course, in this class, we want to use interval notation. So what is the interval of x is greater than or equal to 3/4? I'm going to draw a number line just so you can see it. So here's 3/4. It's going to be a closed circle because of the or equals to part. And the numbers get bigger, because it says greater than, numbers get bigger to the right. So that's my shading here. So you can see here that this shading starts here and it ends all the way, because this shading keeps going, it ends all the way to infinity. So there's the interval notation. Starts at negative 3/4, comma, ends at infinity. And you use a square bracket because it was a closed circle. So what is the overall domain? Well, let's put these two number lines together. So all real numbers looks like, well, everything shaded, right? So this is negative infinity to infinity. The domain of the g function was 3/4 to infinity, right? So this was, I'll write this over here, 3/4, comma, infinity. So I hope this is a purely visual thing. I hope it doesn't take a lot of thought process to see that where do these two lines overlap? They overlap between here and rightwards. So that is your overall domain. Your overall domain is 3/4, comma, infinity. So that is what you would submit as your answer. You would submit, this as the sum and this as the domain. Now, bear in mind, I'm doing a lot more writing than I would expect you to, because it's our notes. If you're going, man, this is a lot of work, blah, 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 I'm just trying to break it down as much as possible for you so you can see all the concepts. And besides, you shouldn't be complaining about being a lot of work anyway. You need to put in the work. Let's do the division here. All right. So it said also find f over g. And guess how we divide? It's just as simple as before. You just put them together. So what was the f function? The f function was x plus 1 over, what was the g function? Square roots of 4x minus 3. Guess what? That's it. There you go. And now we have to find the domain. How does the domain differ between adding, subtracting, multiplying, and dividing? Well, we have to ensure that the denominator cannot equal 0. So, just as before, you just set the inside stuff, 4x minus 3, not equaling to 0. Hopefully this should be very easy, and we get that x cannot equal 3/4. So let's take a look at our original domain. So this was the domain of question number 1. So all that does is, see how there's a bracket around 3/4 that says you can equal 3/4? Well, because now in a division problem, I don't want the denominator to equal 0, you just take that bracket away. So the domain here will be the same, except an open parentheses, because we want to exclude 3/4. So that's really the only difference between adding, subtracting, multiplying compared to dividing. You just have to ensure that you exclude the value that would make the denominator equal to 0. Right. Let's just do one more here. And I'll try to make it, quote, hard. Let's do 2 fractions. Right. So let's say that if f of x equals 3 over x plus 4, and g of x equals x over x minus 1, find f. I'm not going to do adding, subtracting. I think you guys get the idea. Let's just do division. Find f over g and their domains and its domain. So let's do the easy part first. F over g is literally just taking the f function, 3 over x plus 4, and dividing it by the g function, x over x minus 1. Right? The only thing that's different is I do not want you to leave it like this. We have to simplify this. Now, recall from, I don't know, middle school, elementary school, when your teacher taught you that dividing by a fraction is the same thing as multiplying by the reciprocal. So now you just multiply straight across. You can leave it in factored form like I'm doing. You just literally put it together. Or if you don't like that, you can just go ahead and distribute. Now we need to find the domains. So to find the domains, again, you got to find the domains separately and then take the overlap. So let's find the domain of f, which was 3 over x plus 4. So ask yourself those 2 questions. Do we have any dividing going on? Yes. Do we have any radicals going on? No. So we only have to focus on the dividing. And we need to prevent dividing by 0. So I'm going to set the denominator not equal to 0, and then you solve. That should be easy. X does not equal -4. Do the same thing with the g function. So what is the domain of the g function? X over x minus 1. Again, we have fractions, so you set the denominator not equal to 0 and solve. You get x does not equal 1. Last but not least, you have to set the denominator of the overall answer. So here's our overall answer here. So domain of 3x minus 1 over x plus 4. And again, we have fractions, so you set the bottom not equal to 0. Now, since this is in factored form, we're going to have to set up 2 equations. This x here cannot equal 0, and this x plus 4 here cannot equal 0. So this gives us x does not equal -4. So what is our overall domain? Your overall domain is just put everything together. This guy, this guy, this guy, this guy, all of them are your domains. Well, we do have some repeats, and that's okay. But let's see what that means. That means if you imagine a number line, and everything is shaded to begin with. Everything is shaded to begin with. What you have to do is sort of eliminate the yellow pieces, eliminate what you found in the domain. So let's mark our numbers here. So we have, let's say -4 is over here, let's say 0 is here, and let's say 1 is here. According to our math, this domain can't be -4. So at -4, I'm going to erase. According to our math, it can't be 0. So at 0, I'm going to erase. And at 1, I'm going to erase. What's left over are these gaps here. So I hope we can see that our domain is broken up into 4 pieces. This piece, this piece, this piece, this piece, and now all we have to do is write it out in interval notation, right? And by writing out this way, by doing a number line, you can just see it. What's the first interval here? You start at -infinity and you stop at -4. -infinity, comma, -4, and they're both parentheses because it's open. In intervals, you use a union if you want to connect multiple pieces. Where does the second piece start and end? It starts at -4 and ends at 0. Union. What about the third piece? Starts at 0, ends at 1. Union. What about the last piece? Starts at 1, goes all the way to infinity. So that's sort of it. That's how you find the domain and the overall function when you divide functions. How do you divide? You literally just put them on top of each other and simplify. How do you find the domains? You find the domains of the individual pieces, find the domain of your answer, and then just put all of them together on the number line.